Alright guys, I'm here on Friday on your day off. Hopefully you guys are all enjoying your sleep. It's 7:30 and I'm making a video for you guys to help you guys do worksheet 7 after our lab. I'm going to do a couple of different problems, both radians and degrees, to see what we can do. So the first one I'm going to look at is the cosine inverse of root 2 over 2. Okay, so first thing you have to do is go, what kind is this? It's a little c. So that means we're going to get all our general solutions, our general values for this one. Okay, so to do this in the calculator, you need to first look at your mode, make sure it's in radians, which mine is not, so I will fix that right now. And then it says do cosine inverse of root 2 over 2, so that is what we will do. So I'm going to do second cosine, which is cosine inverse of square root of 2. And again, most of you guys should know this hopefully from your unit circle anyway, but if you don't, this is what you get. That's not a nice number, but remember this answer includes pi, so we want to take the pi out. So we're going to divide by pi, and then we get our fraction. And it should be 1/4 or 0.25. And you can always just do math fraction to double check it. So our one angle is pi over 4. Which makes sense because at root 2 over 2, the inverse cosine and inverse sine of root 2 over 2 are both pi over 4 because that's where they are the same on the unit circle. Now we go to, so remember that is your principal value. So if that was big cosine, we'd be done. But it's not, it's little cosine. So now we have to look at our unit circle and figure out where cosine is also positive root 2 over 2. So we're going to have a reference of 45 degrees. And again, or pi over 4. The other place that cosine, which is x, is positive is in quadrant 4 down here. And remember, the second angle I always want positive. So the second angle you always start at 0 and go all the way around to this. And what you guys should realize is that this reference is also a 45 degrees. So that means my angle would be 315 degrees. And if you convert that to radians, think about what 2 pi is. 2 pi is 8 pi over 4. Take away one of the 45 degrees, we get 7 pi over 4. So those are your two angles, and then you just have to add all the other general solutions. And since we're in radians, we do 2 pi k, or 2k pi, I don't care which way you write it. And this is my answer for number 2. Let's do one of the tangent ones, because I know tangent can be tricky. We did sine already in class. We did number 1 pretty much in class together. So let's do tangent. Alright, basically tangent, we did that chart. These are the two values you'll see for tangent, or you'll see one for tangent, but these are like the 30 and 61. And you have to figure out which one is which. Well, I'll do number 5. We can use our calculator to figure this out. Get our first value by doing second tangent of the root 3, and you get enter. You hit enter and you get that. Well, again, we need to divide that answer by pi so we can find out what our fraction is, and it should be pi over 3. This should be 1/3, yes. So so you get 1/3, and that makes sense because this number here is bigger than the root 3 over 3. So the pi over 3 is 60 degrees. That's where your y is higher, which makes sense. We want the y on top of tangents y over x or sine over cosine. So the y on top is higher, you get a bigger number. So you get the answer of pi over 3. Now with tangent, remember, you don't have to draw the unit circle to find the second angle. They're always at 180 degree intervals, or pi intervals, because that is how often tangent repeats itself. So all you have to do, since this is little again, little arc, we have to just add our pi k. Again, it's pi because it's tangent, and that's our final solution. You don't even have to look at that. Alright, well, I'm going to go now and do a couple of degree ones. These are all these big ones, so 7, 8, 9, 10, 11, and 12. Use your calculator, get the value, and you're done. Remember, big arc or big sine inverse, cosine inverse, tangent inverse, you just use the principal value. So let's now go to degrees, because these can be a little more tricky because they're not our unit circle angles. So let's switch our calculator to degrees. to work on the second part of this worksheet. And let's pick, I haven't done sine yet, so let's do arc sine of 0.3907. Again, first thing you do, you go to your calculator, second sine of 0.3907, and you get 22.998. Now, I want nearest minute, so we go to second angle, and number 4 is DMS, so I just hit 4. And there's answer to degrees, minutes, seconds, and we hit it. And basically this is 22 degrees, 59 minutes, 53 seconds. Well, the 53 will round the 59 up, and then the 59 will go to 60, which rounds up to 0 and makes this a 23 degrees, 0 minutes. So this actually is 23 degrees. Okay, so that's a kind of a nice angle. So let's look at that where that is on a circle. Okay, 23 degrees is about here. Okay, where is the other place that sine is positive? Because we're dealing with sine. And again, we're doing all these because we have a little a, little arc sine. We look, and now for sine, sine is your y, so we need a positive height just like this one, and that would be somewhere over here, where our reference is the same angle of 23 degrees. So we need to find out, though, the positive angle from 0. So the full angle would be a full 180 but minus the 23. So when we do 180 minus 23 plus, you should get 157 degrees, 0 minutes. So the other angle is at 157 degrees and 0 minutes. Now, since these are in degrees and since we have little arc, we need to add all our infinite many possible solutions. We have 360k and 360k. And there are our final two solutions, or our final solutions for that problem. All right, let's do a cosine one, and then again for all the big and little, all the big ones. So 18 to 22. You should be able to do just inverse cosine, inverse tangent, inverse sine, and use your calculator value. All right, let's look at number 14. Let's do 16, so I have space. Second cosine of 0.9310. You hit enter. We get a solution of 21.408, so we convert that to degrees, minutes, seconds, because that's what we want to work with. And you should get 21 degrees, and then again, look at the seconds. It's over 30, so this goes up to 25 minutes. So our first angle, and again, little arc means we need all the solutions. Actually, we're on this one, little c. We get 21 degrees, and we get 25 minutes. Okay, so that's our first angle. Let's look at that on the unit circle. I'll do the circle over here. 21 degrees is like right here about. 25 minutes. Now, we're dealing with cosine. We're dealing with cosine here, which means we need the other positive x. So the other positive x would be right here, because it's still in the positive x direction with a reference of 21 degrees, 25 minutes. But I want the positive angle. So basically, I'm almost going all the way around. I'm just doing 360 minus this reference. So since this angle is already in my calculator, I'm just going to say 360 minus my answer. And I get that. I'll just really quickly convert that to degrees, minutes, seconds to make sure it's correct. So because that's 21 degrees 25, our other angle is 338 degrees and 35 minutes. Which makes sense, because then these will add up to 60, which will bump one more of those up, and then we get to 360 when we add those together. Alright, so we got our two angles. We're in degree mode, so we just add our 360k because we're dealing with cosine. Sine and cosine both have periods of 2k or 2 pi or 360. So that is how you do number 16. Okay, so really, again, the process is use your calculator to get the first angle. Then see what your letter is. If it's a small letter, you have to find the second angle, unless it's tangent. Tangent, you're done either way. You just have to either add the 180k or the pi k, or you don't. With sine and cosine, you have to draw the circle and figure out where the other angle would be. So cosine is in x direction. I need a positive x. I have a positive x down here as well with the same reference angle. They're the same distance away. So once you get that, you get the second angle, and then add your multiple revolutions either in degrees or radians. Alright, let's look at these down here because we didn't do any of these. But these are pretty much saying, and this you can actually type into the calculator. Find the angle measures to the nearest minute and trig ratios to the nearest 10,000th. Okay, so arc cosine, again, we want big arc now, so we want a value, is basically saying cosine inverse of the sine of 30. Well, to do that on the calculator, do sine of 30 first, and you get 1/2. And now what they're asking is, what is the angle where cosine is 1/2? Okay, so we do second cosine of our answer, and this should be 60 degrees because cosine is 1/2 at 60. So this is actually 60 degrees, 0 minutes. Let's do number 26. Okay, let's do number 26. Now, before I actually do number 26, notice how 28 and 27 are little tangent, little cosine. It doesn't matter. I'm not talking about the inverse for those. I'm not talking about arc, or I'm not talking about cosine or tangent inverse. So that just means you're finding a solution for the trig function. I'll do that one next. I'm going to do 26 and then I'll do 28. So 26, just type in tangent of 15. You get a solution. Just leave it as a generic solution. Don't round anything. I'm going to leave it like that. And then just sine inverse the answer. So we're looking for the angle for where sine is that value. And you get an angle of 15 degrees and, well, we'll convert it to degrees, minutes, seconds. And we get 15 degrees, 33 minutes. Don't forget to round up. And finally, let's look at 28. 28, I'm asking for an angle. Oh, I guess these are also like that. I didn't realize there was 2 more. So all 4 of these, I'm asking for trig, the value of the trig function. I'm not asking for an angle. I'm asking for an angle in here. This is basically saying, what angle is the tangent 1? If you guys remember, tangent is when x and y are the same, or 1 is when x and y are the same. So tangent's y over x. So we are going to go from that. Okay, so I'm going to type in tan inverse of 1. And like I said, I think I was saying you should know that this angle is at 45 degrees. And sure enough, it is at 45 degrees. So now they want to know, what is the sine at 45 degrees? Well, you guys should know the exact value of that. It's root 2 over 2. However, they want it to trig ratios to the nearest 10,000th, which is 4 decimals. So let's just type in the sine of 45 degrees. And we get 0.7071. Okay, which is, again, the square root of 2 divided by 2. Because we already knew that the sine of 45 is there. So, anyway, when you see just these, be careful. These are not inverse. These are just standard trig functions, what we were doing before in our calculator. We're not doing second sine, second cosine, second tangent for those. That's why the little doesn't matter. It's not defined for the regular trig function. It's always little for those. We just define, because they're always a function, we just define the inverses as big or little based on if it's a function or not. So, all right, well, I hope that helps. Again, I hope you're enjoying your day off, and I will see you guys on Tuesday.